through the ureter, the wall of the tube that carries urine from kidneys to urinary bladder. And the third one will be a section through the wall of the urinary bladder, which, remember, is used to temporarily store urine before it's expelled from the body. And you can follow along on your lab objective sheet. If we turn to the second page, page 13, okay, under ureters or ureters. We're not quite there yet, but we will be. We're first going to look at the kidney. What you're looking at here is a section through the kidney. And one of the things I want you to be able to do is to distinguish between the two regions of the kidney, namely the cortex and the medulla. Which is this, cortex or medulla? And how do we know? It is the cortex because of these. What are these things?
Bowman's capsule.
Bowman's capsule surrounded by the collecting chamber, which is called the glomerulus surrounded by the Bowman's capsule. We call that a renal corpuscle. These are roughly spherical, and if you notice those models, remember I told you the cortex is lighter and appears granular, because this is where you have your renal corpuscles. So in the slide, when you see these, you know you're looking at the cortex, because the renal corpuscles are confined to the cortex. We do not see them in the medulla. And again, the renal corpuscle consists of this capillary network here called the glomerulus or glomerular capillaries, surrounded by the collecting chamber, which is the Bowman's capsule or glomerular capsule. You've also got sections through many tubes here, most of which are parts of the nephron. Namely, proximal convoluted tubules, distal convoluted tubules, and parts of loops of Henle are all found here in the cortex. In fact, the majority of the nephron is found in the cortex. There's only one part of the nephron that is found in the medulla. Anybody know what it is? Loops of Henle, or parts of loops of Henle. You can see it on the model. Remember, that's the part that gets down to the cortex in the medulla and goes back. Now, this is for both nephrons, both cortical nephrons, which have the shorter loop of Henle, and the juxtamedullary nephrons, which have the very long loops of Henle. Okay? So the only part of the nephron found in the medulla, loops of Henle, or at least part of loops of Henle. Okay? Everything else, renal corpuscle, proximal convoluted tubule, distal convoluted tubule, and again, part of loop of Henle in the cortex. Okay? So if you see these, you know you're in the cortex. That's the first thing you should look for. Now, I'm not going to ask you to distinguish between these various tubes, most of which are cut in cross-section here, although you can distinguish them, but I want you to know what they are. So if you ask these tubes out here, you tell me proximal convoluted tubule or distal convoluted tubule or parts of loops of Henle. Okay? However, in this case, I think it's fair game to ask this. What tube is this?
Proximal.
Yeah, because it's coming right out of the Bowman's capsule. They're connected to the Bowman's capsule. So in this case, we have a longitudinal section that's attached here to the Bowman's capsule. You know it's a proximal convoluted tubule. So I could ask that. All these sections here, I won't. But you just need to know what they are. And again, this would be the glomerulus. Okay? Now, most of the renal tubule, the wall consists of simple cuboidal epithelium. Simple cuboidal epithelium. But there are some exceptions, and one is right here. The wall of the Bowman's capsule, the glomerular capsule, is not simple. It's not simple cuboidal, but instead it's what?
Simple squamous.
Simple squamous. See the single layer flattened nuclei here? So that's an exception. Also, the so-called thin segments of the loop of Henle. And on those models you see some parts are very thin and some are thicker. The thicker ones are simple cuboidal again. The thin segments of the loops of Henle are also simple squamous. Another place where you see a change in the epithelium is in the macula densa, which is part of the juxtaglomerular apparatus. And those are specialized cells in the walls of the distal convoluted tubule. You can see it on the model. They tend to be higher profile. They're more like a simple columnar instead of a simple cuboidal. Okay, so most of the renal tubule, okay, most of the nephron, the wall is simple cuboidal epithelium. Again, the exceptions, simple squamous, the wall of the Bowman's capsule, simple squamous in the thin segments of loop of Henle, you see those on the model, and simple columnar in the macula densa. It's a specialized region, okay, cells that make up that juxtaglomerular apparatus. right up next to the veneers. Okay? So take a look at those on the models. You can see that. Any questions on this? All right. Oh, and by the way, we got another tube here that is not part of the nephron, in the cortex. What is that? Collecting duct. The collecting duct. Remember, that's what collects urine from the distal convoluted tubule.
Not visible on the slide though?
Do you have to identify them on the slide? No.
Oh, okay.
I'm not going to ask you to identify these tubes, but you need to know they're there. Okay, what they are. All right, here you can see we're out of the cortex, now we're in the medulla. And you can see a lot of sections through tubes. You can see some here cutting cross section, and some down here. You can see more longitudinal. These tubes. And that's what gives the medulla a striated appearance. All these tubes, roughly parallel one another. What kind of tubes are they? What tubes run through the medulla? The what? Loops of Henle, all right. It's one of the types of tubes. What else?
Collecting ducts,
Collecting ducts. Anything else?
blood vessels.
The what?
Are there any blood vessels?
We're talking about kidney tubules.
No.
There are blood vessels, yes.
What's under the collecting ducts,
Okay, distal cortical. Capillary duct. Capillary duct. All right, so the three types of tubes you see in here would be loops of Henle, parts of loops of Henle, collecting ducts, and capillary ducts.
Yes.
If you're asked what part of the nephron, your answer would be what tubes?
Oh.
In the medulla. What part of the nephron? What
Loops
tubes?
of
What are the
Henle.
blood vessels?
Loops of Henle.
Loops of Henle. Okay, only loops of Henle. Proximal convoluted tubule, distal convoluted tubule, the rest of the loops of Henle will all be in the cortex, as well as the renal corpuscles. All right? Okay? Again, I'm not going to actually distinguish these so you know what kind of tubes they are. I won't ask on the slide which one is this or that. All right?
Thank you.
Any questions on the kidney? It's really not that bad. All right, let's look at a section through the ureter or ureter. Again, this is the tube that carries urine from the kidneys to the urinary bladder. And there's one associated with each kidney. This is cutting cross section. And on this you can follow along on your lab objective sheet on page 13. If you look under ureter, it says this is toward the top of the page under process involved in urine formation. Everybody see that?
Yeah.
Okay. The epithelium, that's the first thing listed there, is what? Transitional epithelium. And what do we mean by transitional epithelium?
A change.
It means the cells change shape according to the amount of pressure put on the organ wall. Now in this case there's no pressure because it's empty. So it appears to be a stratified cuboidal or column. And you can tell by the shape of the nuclei. Okay? This is the epithelium. You can see it's thrown into folds. There's no pressure on it. So you can see multiple layers here, basically a spherical nuclei, like a stratified cuboidal epithelium. As urine passes through, of course, that distends or stretches the wall. Then what would this epithelium look like? What kind of tissue?
Would it look like squamous?
Stratified squamous, like a non-keratinized stratified squamous. And as urine passes through, of course, it's stretching the wall, so it's going to cause these cells to flatten out. All right? All right, deep to this is your mucous membrane again. We have areolar connective tissue right in here. It's kind of that blue-gray layer. What is this?
The lamina propria.
Lamina propria again, just like we saw in the GI tract wall. Remember, this is a mucous membrane lining. The epithelium is different than what we saw in the GI tract, but it's thin. Lamina propria is the same. Okay? Then external or deep to that, we got our muscle layers. Again, it's smooth muscle. We got two layers here. So if I ask cell type, you would say smooth muscle. And the arrangement, how those fibers running. The inner one is what?
Longitudinal.
Longitudinal, unfortunately. It's Not circular, which you learn in the GI tract, it's just the reverse. So it's inner longitudinal, then outer circular. Okay? So again, cell type or tissue type would be smooth muscle. And again, the arrangement, the inner one here is longitudinal smooth muscle, the outer one is circular. Now it's hard to tell them apart. So it's up here, and it's right next to the lamina propria. You may assume that it's longitudinal smooth muscle. It's out here on the edge, okay, then it's circular smooth muscle.
Would that be the muscularis?
Yes, this is a
mucosa?
muscularis external. Yeah,
External.
yeah,
Okay.
it's a
Not
muscularis,
mucosa?
it's a muscularis layer, okay? Right?
Okay.
But it's similar to what you see in the GI tract as far as the layers are concerned. It's not exactly the same because you don't have the muscularis mucosa and so on.
Oh, okay, so it's just the muscularis external.
Right.
Okay.
So it's at the muscle layers. Smooth muscle, longitudinal, smooth muscle, circular. Or you say longitudinal smooth muscle, circular smooth muscle.
And
All
that's
right.
the ureter.
Next side, outside that, you got more connective tissue. You can see it here, it's kind of a grayish layer. It's got a lot of blood vessels in it.
Looks like adipose.
No, this isn't adipose. This right here is adventitia.
Okay.
The
well, I meant
adventitia.
one, yeah.
Okay? So here's your smooth muscle layers again. Here's your epithelium, transitional epithelium. Here's your lamina propria. Here is the inner layer, that's the longitudinal smooth muscle. Out here would be the circular smooth muscle. And then the adjacent connective tissue on the outside, this is called adventitia. It's a thicker layer of connective tissue. Yes?
Did you call the lamina propria the submucosal membrane? Did you refer to that in that name?
No, it's not submucosa.
I didn't think so, but I thought
It's just called lamina propria. And remember, the submucosa is different than the lamina propria. That's actually part of the mucosa, lamina propria. It's the mucous membrane. So you got your epithelium and you got your lamina propria, all part of the mucosa. Okay. External to the adventitia, we have more connective tissue, and this one is what?
Adipose.
That is adipose. For some reason, I don't know why, but A&P students, when they come out of A&P 1, have often forgotten the tissues, but there's one tissue they remember, adipose. Okay? Which is fortunate because you got adipose almost everywhere. You know, bottom organs, below the skin, and so on. Okay? So once again, go through the layers. Here again is the wall and cross section. So again, this inner layer, that's the epithelium. Transitional epithelium, there's the lumen where the urine would flow. This layer here, this blue-gray, lamina propria. The red layers here are the smooth muscle, inner longitudinal, outer circular. Here's your adventitia. See a lot of blood vessels in it. Okay, and now here, this big layer of adipose. Okay. Any questions on this? Okay. Let's look now at the wall of the urinary bladder. And again, we're going to see the same layers. And again, the epithelium that we saw in the ureter is the same as what we see in the urinary bladder. Now you can see the wall is still in the folds because there's no pressure on it. But again, this kind of a lavender color here, that's the epithelium. And again, it's transitional epithelium. Okay? This kind of pink stringy stuff, deep to it, again is lamina propria. Okay, that's that loose connective tissue. And then we go into the muscle layers. Then we go to the edge of the organ here. Okay, so again, here's the epithelium, transitional epithelium. This kind of pink stringy stuff here, this is the lamina propria. And here is one of the muscle layers. Again, it's smooth muscle, and again, it's longitudinal. Now, the urinary bladder wall actually has 3 layers of muscle. The inner one is longitudinal, then it has a middle circular layer of smooth muscle, and then an outer longitudinal layer of smooth muscle. And actually, the distal part of the ureter or ureter is the same. It has 3 layers. But it's always the inner one, longitudinal, and the one outside that is circular. If there's a 3rd layer, it's outer longitudinal. Okay, so this first layer that we see here, which is adjacent to lamina propria, this is longitudinal. Longitudinal smooth muscle. Okay? And we move down here, okay, circular. That's the middle layer. And we move a little farther out. Okay. This region right here, and we get into the outer longitudinal muscle layer. And on the very outside, you see, there's more of the longitudinal. On the very outside again is adventitious. Excuse me. So when we look at this again, okay, again, here's the epithelium, transitional epithelium. Here's the lamina propria. And here is the smooth muscle, the inner layer, which is longitudinal smooth muscle. And your middle layer here, as you see in here, this is the circular smooth muscle. And then out here, again, you're in your longitudinal smooth muscle. Now, it's hard to tell them apart, I think you'd agree. If you're out on the edge of the organ, and you can see the adventitia beneath it, okay, on one edge, that'd be longitudinal smooth muscle. If you're up at the other end or interior of the wall, up here, okay, your adjacent lamina propria, again, that's longitudinal smooth muscle. And it's in the middle where you got muscle on both sides, okay, like we have in here with muscle here and muscle there, that'd be your circular layer of smooth muscle, okay? But again, if I put a point on one, don't give me the whole wall. You don't need to impress me with your knowledge. Just say, okay, it is smooth muscle, how's it arranged? Longitudinal circle. If you put the whole wall, I'll ask which one, all right? So please answer the question, all right? Don't go through the whole wall. Okay, that's it. Any questions?